So we're continuing our unit on parallel lines today. One of the things you have to be careful about when you're doing parallel line problems is there will frequently be lines that look like they're parallel, but you don't know for sure that they are parallel. Remember, we don't assume that lines are parallel just because they look like it, or perpendicular just because they look like it. Okay? So take, for example, this problem. I mean, it appears that these two horizontal lines, or these two lines, are actually horizontal and that they are parallel, but we don't know that for sure. So because of that, there's no relationship between the 54-degree angle and this angle number 2. Okay? Instead, the 54 is related to the angle at 1. You always want to be working across the parallel lines. So one of my regular geometry students yesterday when I was working with them was talking about, well, I always want to go with the arrows. And I'm like, no. With parallel lines, you want your transversal to go across the two with arrows on them. So if this angle is 54, what type of angles are angle 1 and this 54? Yeah, because they are same side interior. So just subtracting that from 180, we get that this angle is 126. So what type of angles are 1 and the 64? They're alternate interior, but because I don't know that these two sideways lines, I'll call them, are parallel to one another, I don't know that they have any relationship to one another. But I can, again, work this way. And what type of angles are the 64 and angle 2? Alternate exterior. So this angle is 64 degrees. Alternate exterior angles being congruent to one another when you have two parallel lines that are crossed by a transversal. Likewise down here, very similar looking diagram. I had a student once that called these, weird tic-tac-toe diagrams, or enormous hashtags. But it's the same idea. Here, what kind of angles are 1 and the 67-degree angle? They're corresponding. But do I know that they're related to each other in terms of their size? No, because I'm not going to cross the parallel lines. If I want to find angle 1, I've got to use this 123-degree angle down here. Those two are same side interior angles. I'm going across the two parallel lines, so they are supplementary. So this is 57 degrees. Yes, sir. That means that these two lines are parallel. Just 'cause. Yeah, no, there is no special meaning, whether it's 1 or 2 or 17. Although if you had 17 of those on there, it'd be a little ridiculous looking. And then over here, angle 2 is going to be related to the 67, but not directly. And there's many ways that you can do this, but 2 and 67 aren't any kind of angles.
Opposite x.
2 and 67 aren't any kind of angles.
Oh yeah, none.
Right. So, because of that, we can't do anything directly, but this 67-degree angle corresponds to this one. And I think corresponding angles are the easiest ways to move around. And then what kind of angles are 2 and 67? Or 2 and this new 67? They're linear pairs, so they are supplementary. So subtracting 67 from 180, we get that this is 113 degrees. So in a lot of the problems that you're going to be doing, you have to make sure that the two lines are actually parallel before you just start willy-nilly applying the rules to them. All right, let's move on to this next one. So which angle is angle 1 related to in terms of its size? The 128 or the 123? The 123 because I want my transversal to cross the parallel lines. So these are same side interior angles. Subtracting from 180, we get that angle 1 is 57 degrees. And then for angle 2, which one is it related to?
128.
The 128. Again, I want my transversal to cross the parallel lines. So subtracting from 180, we get that this angle is 52. Any questions about those? Okay. So today you're going to learn about a new kind of problem. Geometry is typically the first place that people learn about it. It's called a proof. You're given some information and you're asked to prove that something is true. Okay? You're almost always given a diagram. In this class, you'll always be given a diagram along with it. And I'm going to teach you a couple of different ways to write this. The format is going to be up to you. I'm going to show you two different formats that you can use. Some people like one of them, some people like the other one. I don't care, one way or the other, okay? I'm not big on, you have to do it this way. Like, as long as it's good math, I don't care. So, here's what we're going to do. We're given in this diagram that line R is parallel to line S and that line A is parallel to line B, and we want to prove that angle 1 is congruent to angle 3. So, one way that we can do this is what's called a two-column proof. It's like an enormous T-chart. And on the left, you're going to have statements. Statements are things that you're asserting to be true. But for everything that you assert to be true, you must have a valid reason as well. Now, your reasons will be theorems and postulates that you know, definitions, occasionally a property, right? They are general things. In the statements column, you're making a specific statement that applies to this specific situation. So let's take a look. I always start with all of the given. You'll find later on, when you're doing some of the ones in the book, that your book will break up the given into different parts. The reason that they do that is they do one given and they use it, and then they give you another part of the given and then they use that. I'm like, I don't have time for that. Okay? So I'm going to go ahead and mark that R is parallel to S and that A is parallel to B. My goal is to get from here to the prove statement, giving reasons as I go, that 1's congruent to 3. Well, if I'm trying to prove 1 and 3 congruent, I always try to start with, well, what do I know that's kind of like saying 1's congruent to 3, or that looks similar to this, has some parts of that in it? Yeah.
I guess you could say 1 equals 2, and then...
Okay, I'm going to take exception to your use of the word equals.
Or 1 is congruent to 2.
Okay, so let's start there. Frequently when you do these, you're going to start and you're not sure how you're going to get there every time. Some people, you're going to get good at these easy ones, and later on you're going to have ones that are longer and you're just like, I don't know how I'm going to get there, but I know how I should start, and you just have to start, right? Some of you will get to the place where real quickly you look at this and you go, I know all the steps that I'm going to do, and you're just writing. But you want to start with something that looks kind of like what you want to end up with, if at all possible. But I have to give a reason for that. How do I know that angle 1 and angle 2 are congruent to each other? Opposite. We're again with you got to know the right words. So this is the alternate interior angles theorem. You're welcome to abbreviate just like I've done here. Please do not just put alternate interior angles. Some people are like, well, what about them? Your choices are to either write out the name of the theorem like this, or you can write the whole theorem, which says, if two parallel lines are crossed by a transversal, then any pair of alternate interior angles formed will be congruent.
Okay.
Most people choose to write the title. But if you're going to write the title, it needs to be the whole title, not just alternate interior angles. Now, how is this different than what I want? Yeah.
You don't have 1 is congruent to 3 yet.
Right, I know that. How is this different than this? What's different? Or maybe I can ask, what's the same? Do I have an angle 1?
Yes.
Yes. Do I have a congruent sign?
Yes.
Yes. Do I have angle 3?
No.
No. I have angle 2 where I want angle 3. I'd like to be able to replace angle 2 with angle 3. Well, let's take a look. So far I know angle 1 is congruent to angle 2. What should I know about angles 2 and 3?
2 and 3 are congruent.
Because they are what type of angles?
Corresponding
They're corresponding angles. All right. So angle 2 is congruent to angle 3. And that's the corresponding angles postulate. It's the only one that's a postulate. And the reason it's a postulate is because at the beginning we just said, these look like they're the same size, and we're all going to agree that they are. So now, look what I've got. Angle 1 is congruent to angle 2, and angle 2 is congruent to 3. If I know those two things, what should be true about 1 and 3?
1 is congruent.
Yeah, angle 1 is congruent to angle 3. But we need to give a reason for this. Now, I take a very, I don't know, loose interpretation for this next part. Some geometry teachers would be appalled that I allow you to do this. I'm like, get over yourself. It's not that big a deal. There are two different things that you can give for this. One is this idea. I've taken angle 2 out and replaced it with something that's the same size. Right? That seems fair, yes? Okay. In volleyball, when you take somebody out and you replace them with somebody else, what are you doing? Subbing, which is short for substitution. This is the substitution property. Now, for those of you, I'll switch sports on you who are football fans. If I was to take out my left tackle and replace him with my field goal kicker, what's likely to happen? Pardon? What? I just didn't hear you. No. If I took out the tackle and in his place I put the field goal kicker, yeah, is that going to be a good substitution? No, not likely to be the same size. Rarely do you see field goal kickers who are the same size as your left tackle. You can only replace something with something that is the same size. Now, Why are other geometry teachers appalled that I would let you do this? Well, because technically speaking, the substitution property can only be used for things that are equal. So if you want to get super technical about it, you have to change this to the measure of angle 1 equals the measure of angle 2, and the measure of angle 2 equals the measure of angle 3. Both of those are true by the definition of congruent angles. And then you substitute, and then you change it back to congruent. Bleh. Like, that feels to me like, do you guys know what hoop jumping is? You ever heard that phrase?
It's a term for doing something unnecessarily.
Yeah,
long.
typically it's for things where it's like, yeah, it's a nice trick and all, but who cares, right? It has to do with either circuses or like you can have dogs jumping through hoops, right? It's kind of amusing, but it's not really necessary. If you want to be technical about it, you can do this by using something that's called the transitive property. Of congruence. And what the transitive property says is that if angle A is congruent to angle B and angle B is congruent to angle C, then I know that angle A is congruent to angle C. It's like you make a chain of things that are congruent, and whatever at the beginning and whatever is at the end are congruent to each other. I'm happy for you to use either of those. If you want to use substitution, that's fine. I sort of prefer substitution a little bit because of some other proofs we're going to do. For this one, I really don't care. All right, let's go on to the next page. I left way too much room for these, but that's okay. Let's do this one as a 2-column proof also, and then I'll show you a different format that you can put them in that some of you will like very much and some of you will not. All right, here our only given is that J is parallel to K. The reason I know that's true is because it was given information. All right, I'm trying to prove that angle 1 and angle 3 are supplementary. What type of angles are 1 and 3?
No, they're none.
Yeah, they are nothing. You guys got there pretty quickly. Yeah, they aren't any kind of angles, so I can't use that. I want to prove that angle 1 and 3 are supplementary, but I can't do that immediately. But what can I prove, or what can I state is supplementary? 1 and 2 are supplementary? I don't think so. 2 and 3 are supplementary. Now, we'll talk about 1 and 2 in just a second, but I like to start with something that is as close as possible to where I want to finish. It's a little like playing golf. You'd like your approach shot to be as close to the hole as possible. The question becomes, well, how do I know that those two are supplementary? They're a linear pair. This is the linear pair theorem. Now, this is almost what I want to end up with, right? What's different about it, though? It's angle 2. Can I just remove angle 2 and put angle 1 in its place right now? No. I got to justify why that's legal. Yeah. Angle 1 is congruent to angle 2. How do I know that's true? Yeah, so this is the, there we go, corresponding angles postulate. And this is where I told you that, some geometry teachers are appalled with the other one. They're really, really appalled that I let students do this. And I'm like, again, I want you to understand the idea behind this. I'm not interested in all the minute hoop jumping that you have to do. To do this technically, legally, what you have to do is say the measure of angle 2 plus the measure of angle 3 equals 180 first by the definition of supplementary angles, and that the measure of angle 1 and the measure of angle 2 are equal, and then substitute, and then change it back to supplementary, which just feels really unnecessary. What I allow students to do here is go, well, angle 2 and angle 1 are the same size, so I'm just going to substitute. So this would be angle 1 and angle 3 are supplementary. That kind of rhymes. By the substitution property. You're welcome to abbreviate substitution property. You're just not welcome to abbreviate SUB, because there's also a subtraction property. We don't make use of it, but there is such a thing as a subtraction property. So don't call it SUB. Any questions about that? All right. Let's do a few more of these. I'm going to show you a different format. The format that we've been doing is called a 2-column proof. It's pretty common. This next one isn't as common just because it's not as old. This is called a flowchart proof. And here's how it works. I'm going to write that M is parallel to N. That's a statement. Every statement goes in a box. And underneath the box is your reason. The reason I know that's true is because it's given. And at the same time, I know that J is parallel to K, but that's its own statement, so I put it in a box. Say that that's given as well. Again, I like to try and make my first statement be as close to this as possible. Can I state that 1 and 3 are supplementary immediately? No.
1 and 2.
I could start with 1 and 2 are supplementary. Now, before we write it down, my question is, does that come from knowing that M and N are parallel, or come from knowing that J and K are parallel?
J and K.
Comes from J and K. So since it comes from that, we draw a little arrow over here that says, okay, Because of that, I know that angle 1 and angle 2 are supplementary. And how do I know that angle 1 and angle 2 are supplementary? Yeah, so it's the same side interior angles theorem. Yeah. Same side interior angles theorem. I'm close to what I want, but not quite there. I don't want angle 2. What do I want? 3. And what do I know about angles 2 and 3? Yeah, they're congruent, so they're corresponding. Now, does that come from the fact that 1 and 2 are supplementary? Or that J is parallel to K? Or that M is parallel to N?
Is parallel to N.
It's because M is parallel to N. So this is going to be angle 2 is congruent to angle 3. By the corresponding angles postulate. And then I'm going to put these two statements together and use both of them to take angle 2 out of this and replace it with angle 3 from up here, so that we can say that angle 1 and angle 3 are supplementary. And again, since I've taken, God bless you, something out and replaced it with something that's the same size, that's the substitution property. So I kind of like flowchart proofs because the logic is a little clearer, but I don't like them because when we get to longer ones, these get kind of messy. It is entirely up to you. I will switch back and forth just kind of randomly depending on my mood at the moment. But it's your choice. All right, let's do one more. Okay, and I'll do this as a flowchart proof again, just to practice that. So we start off knowing that J is parallel to K. That's given. And I'll mark that on my diagram. J parallel to K. And then I also know at the same time, so I start all the way over on the left because it's beginning knowledge, that ray BA bisects angles CBD. And that's given information. I would like to say something about either angle 3 or angle 4 that is true at this point. And I'd like it to be based on one of these two reasons.
1 and 3 are congruent.
Okay, I can start with, that's because J is parallel to K. I can start with angle 3 is congruent to angle 1. What's the reason I know that that's true? Yeah, so this is the alternate interior angles theorem. All right, well, I'd like to replace angle 1 with angle 4, but, well, 1 and 4 aren't any kind of angles. I guess 1 and 4 are actually, nope, they're not on the same transversal, so they're not anything.
You can do 1 and 2.
All right, well, what about 1 and 2?
They're congruent because BA bisects CED.
Okay. Well, let's see. So that would be angle 1's congruent to angle 2. Anyone want to hazard a guess as to the reason for that? We haven't used this reason.
Oh, because 1, 2, and B are all supplementary, and then the B.
Oh, no. This is, notice it says we have an angle bisector. The definition of angle bisector is a ray that divides one angle into two congruent angles.
Oh.
So we're using the definition of angle bisector. Well, if angle 3 is congruent to angle 1, and angle 1 is congruent to angle 2, what conclusion can I make based on these two statements?
Then 3 is congruent to 2.
Yeah, based on those two, I can say that angle 3 is congruent to angle 2. And you can either call that the substitution property or the transitive property. But I'm not quite where I want to go yet, am I?
You can say that 2 and 4 are congruent because they're corresponding angles.
Yeah, and that's based on J parallel to K, right? So I'm going to draw another line and go, okay, I know another thing based on that. Angle 2 is congruent to angle 4. What's the reason for that, anyone?
Corresponding angles postulate.
There you go, corresponding angles postulate. And now I can combine these two. If angle 3 is congruent to 2, and then angle 2 is congruent to angle 4, then angle 3 is congruent to angle 4. And again, you can either call that the transitive property. Anytime you have a chain of things that are congruent, we can put the ends together. We can say that's substitution property or the transitive property. Okay, any questions about that? All right, I have a worksheet for you.